In the previous section, we simplified fractions by regrouping the wedges so that we would end up with fewer total pieces. But sometimes we need those extra pieces. Consider the following pair of pictures. In isolation, each picture makes perfect sense, but trying to get them to interact is difficult because the sizes don't work with each other. Specifically, we can't slide slices of one picture onto the other and have all the pieces line up in a meaningful way. In this picture, the pieces are not the same size. However, if we took the same pictures and cut them into slices that are the same size, in this case that means 6 pieces each, then the two pictures will now interact naturally. This idea hints very strongly at the idea required for addition and subtraction of fractions, and we will see that in just a couple sections. Example, use parts of a whole to rewrite 1/4 with a denominator of 12. Let's start with a picture of 1/4. We want to cut up these slices so that we have a total of 12 slices that are all the same size in the end. How can we do this? Hopefully, your intuition is telling you to cut each slice into 3 pieces, because this is correct. This gives us a picture with 3 pieces that are shaded in out of a total of 12. That means we have 1/4 is equal to 3/12. How did you know to cut each wedge into 3 pieces? Where did that number come from? Your brain was doing some math without telling you. The problem asks you to solve the following equation. 4 times something is equal to 12. And because of your experience with numbers, you came up with the number 3 as the solution. We will harness this intuition later. For now, we will just leave it as it is. Example, use parts of a whole to rewrite 2/5 with a denominator of 15. Once again, we'll start with the picture. We're starting off with 5 total wedges, and we want to end up with 15 total wedges. How can we manipulate this picture to get that result? It turns out that we need to take each wedge and cut them into 3 slices. We started off with 2 shaded wedges out of 5 total, and we ended up with 6 shaded wedges out of 15 total. So 2/5 equals 6/15. As you can see from this picture, when the number of slices gets large, the picture becomes very crowded. Notice that when we cut up the original shaded slices into 3 pieces, we ended up with 3 times as many shaded slices. This is the idea of proportionality appearing again. We will now switch over to a symbolic way of writing this out. Example, rewrite 2/5 with a denominator of 15. As we just saw, we need 3 times as many total slices and 3 times as many shaded slices. So we need to multiply the numerator and the denominator by 3. And then we just work out the products. 2 times 3 is 6, and 5 times 3 is 15. Notice that we wrote out the products for both the numerator and the denominator. Simply writing times 3 off to the side would be a substantial error. Correctly communicating this process is just as important as computing the right answer. For this section, your presentation will need to include this step. In all the problems up to this point, you've been told what denominator to use, but sometimes you'll need to come up with that number on your own. Let's go back to the picture of 1/2 and 1/3. Why is it that 6 ended up being the value that we used? If you look at the numbers 2 and 3, you see that 6 is a multiple of both 2 and 3, which means that we're able to make the slices work out evenly. A few sections ago, we called this the least common multiple, and this is precisely the thing that we need to have here. Example, rewrite 3/5 and 1/2 so that they had the same denominator. The denominators we have are 5 and 2. What is the least common multiple of those two numbers? 10. At this point, you should have enough experience to see the answer without having to write anything out. But if you still need to do that, make it scratch work. And now we need to convert the 2 fractions. Starting with the fraction 3/5, we need to determine the value to multiply the top and the bottom by so that the denominator becomes 10. You should quickly be able to see that 2 is the right value for this. When we work out the products, this gives us 6/10. For the fraction 1/2, we need to multiply the top and the bottom by 5. And that gives us 5/10. It is important to use the least common multiple so that you don't end up with numbers that are larger than they need to be. Example, write 5/6 and 7/9 so that they have the same denominator. You could multiply 6 and 9 together to get 54, and that will work, but it won't be the best choice because the numbers will be bigger than necessary. By thinking through the multiples, you should be able to see that 18 is the least common multiple. And from here, we convert to two fractions. For the fraction 5/6, we need to multiply top and bottom by 3. And that gives us 15/18. For the fraction 7/9, we need to multiply top and bottom by 2. And that gives us 14/18.